let's learn electronics. Let me give you a quick recap of पिछले episode में हमने क्या देखा था. So in the previous video I discussed how diode characteristics curve is plotted, and in the forward region after exceeding a certain knee voltage the current rises exponentially, and in case of reverse bias only a nominal current is observed, which is called reverse saturation current, until the breakdown occurs. I discussed the two types of breakdowns, avalanche and Zener breakdown. I tried to explain everything using animations, so if you have not watched the video, please go back to the channel, subscribe it and view all the videos for better understanding. Anyways, let's move ahead and discuss some of the basic differences between avalanche and Zener breakdown. Avalanche breakdowns occurs at a value greater than 6 volts, whereas Zener breakdown takes place at a value less than 6 volts. आसान भाषा में समझें तो एवलांच ब्रेकडाउन को 6 वोल्ट्स या उससे ज्यादा की रिक्वायरमेंट होती है, तब ये ब्रेकडाउन मैकेनिज्म स्टार्ट होता है. जेनर ब्रेकडाउन उससे पहले ही जनरली 4.5 या 5 वोल्ट्स की वैल्यू पर स्टार्ट हो जाता है. Avalanche breakdown is a cumulative process. Cumulative means something gradually increases as the event occurs. So here in case of avalanche breakdown we have a free electron which is so excited, it's jumping and bumping and striking out more free electrons, which are creating even more free electrons, and all the electrons are dancing. So it is a cumulative process. It is happening because of the collision of free electrons which are breaking the bonds. In case of Zener diode, it is not a cumulative process because it is dependent on a strong electric field which is directly rupturing the bonds. जल्दी जल्दी बता रही हूँ क्योंकि ये सब recap है. Avalanche breakdown generally happens in a diode with low doping concentration, whereas Zener breakdown requires a high doping concentration. Avalanche breakdown has positive temperature coefficient. With positive temperature coefficient, it means जैसे जैसे temperature बढ़ेगा वैसे वैसे रिवर्स बायस पे हमें ज्यादा वोल्टेज अप्लाई करना पड़ेगा, तब एवलांच मैकेनिज्म स्टार्ट होगा. एंड जेनर ब्रेकडाउन के केस में ऑपोजिट है. टेम्परेचर बढ़ रहा है, वी नीड लेस वोल्टेज एट द जेनर बैटरी में कम वोल्टेज अप्लाई करेंगे तब भी जल्दी से ब्रेकडाउन स्टार्ट हो जाएगा. एवलांच ब्रेकडाउन इज ऑल्सो नोन एज इम्पैक्ट आयोनाइजेशन प्रोसेस, एंड Zener breakdown is also called field ionization process. It's just a quick overview of the previous video. So far whatever we have learned, it is understood that breakdown is an undesirable mechanism. We don't want the breakdown process to happen because it may permanently damage the device. But in certain situations, we deliberately employ this breakdown mechanism in a diode. We fabricate a diode in such a way that it would conduct in the reverse region. And such diodes which are designed to work in the reverse region are called Zener diodes. Zener diode वो special diode है जो reverse region में conduct करता है, and it will not be permanently damaged. You can understand this in a better way with this analogy. Look at this clip. On your left we have a spaghetti which is indicating a normal PN junction diode. As you bend it, after a certain point it breaks because it's brittle. And on your right we have a hand holding an elastic. Because it's flexible, it keeps on stretching and comes back to its original shape once the force is released. So it is just like a Zener diode. This analogy may not be that accurate, but at least you can relate how a Zener diode works. When reverse bias is applied, it conducts, and when the voltage is removed, it comes back to its original shape. Now let's understand what happens. How we can obtain a Zener diode. We increase the dopants, we diffuse more dopants in the P and N materials so that they are highly doped, they have high doping concentration. So we are introducing more dopants and we combine and make a diode just like a normal PN junction diode, but because of the high doping concentration, this depletion width, this junction area is thin here. it is lowered, it is reduced because of the increased dopants. And as it is thin, it is developing a strong electric field across it. The junction has got a strong electric field, and if you remember this formula, E is equal to V by D. E and D, they are inversely proportional, so here D is less. D is reduced. This distance between the depletion region, it is reduced, so we have got an increased E, an increased electric field. Electric field is strong here. And what happens with this strong electric field? As we apply reverse bias, this electric field is becoming more powerful. Let's zoom into the depletion region. As this electric field is increasing and increasing, let's zoom in. Forgive me for my poor drawing, but just imagine that these are the free electrons which are coming out of their covalent bonds. These free electrons are kind of pulled out because of the strong electric field, and now this depletion region is suddenly ruptured because of the electric force applied on the junction. And if we look at the graph, in the forward region it works just like a normal PN junction diode, so you won't find any difference. And in case of reverse region, here it will provide some reverse saturation current, but then this Zener breakdown occurs, and here we are getting a high current, the voltage across this point, this Zener breakdown voltage will remain almost constant, and we are getting a high flow of current. This is generally denoted with IZ, and the Zener breakdown voltage is generally denoted with VZ or sometimes VK. This is how with this symbol a Zener diode is generally denoted or is shown in the text and circuit diagrams. This is a normal PN junction diode with a straight line, but here as you can see that this has got a symbol which resembles with the alphabet Z. So wherever you see this kind of symbol in any circuit diagram, just understand, just quickly recall that this symbol is of Zener diode, and a normal PN junction diode allows current in forward direction only, in the direction of this arrow. But in case of in case of Zener diode, it can allow, and it is actually designed to allow the flow of current in the opposite direction, in the reverse direction. And here is a picture of the practical diode. Generally a normal PN junction diode looks like this. This ring indicates the cathode, and this is a practical Zener diode. Here is the cathode. It also has a ring indicating the position of cathode, and the current flows in the opposite direction. This entire theory was given by Sir Clarence Zener, the first physicist who actually told us about the Zener mechanism, and this is the reason why the device is named after him, after his surname. These are some of the common specifications of a Zener diode. Zener breakdown voltage is the voltage at which the breakdown occurs, and it generally varies from 2.4 volt to 200 volt. This value actually depends on the doping concentration a device would have. Then current IZ max, which indicates the maximum amount of current rated at the Zener voltage, the maximum amount of current a diode can allow to flow through it. And IZ minimum is the minimum amount of current which is required for the diode bias to start the breakdown process, and it lies between 5 milliampere to 10 milliampere. The power rating indicates the maximum power which can be dissipated by the Zener diode, and the typical values are mentioned here: 400 milliwatt to even 5 watt. The best temperature stability is observed in diodes of around 5 volts. The voltage tolerance value is generally plus minus 5%. That means an increase or decrease of 5% can be tolerated. And Zener, there is some resistance in the device as well, which is called Zener resistance, and it can be calculated with this formula, the general formula. Zener diode is used in various electronic devices, but the most popular application is in the voltage regulation circuit. The the most common use which you will find in almost every text is the application in voltage regulation circuit, but it is also used in clipper circuits to shape the AC waveforms. It is used for overprotection as over voltage protector, along with the SCR. We'll know about these devices and these applications in detail in the upcoming videos, so wait for them. We will also try to practice some numericals based on these Zener diodes. So wait for the next videos. And in case anybody is any of my viewer is writing dissertation or assignments, or you are stuck up in any academic task and you need some assistance, then please feel free to contact us on this email ID. We'll get back to you, and we are ready to help you in any writing task which you are doing these days. So please like, share and subscribe the channel. Wait for the next videos and subscribe it to get the updates regularly. Thank you for watching the video. Bye bye.